Let us start noble gases. These noble gases coming under group 18 as per IUPAC. As per IUPAC 18th group, as per European 0 group. What are the elements in this group? Helium, neon, argon, krypton, xenon, radon. Before that means during Mendeleev's periodic table, during Mendeleev's table time, these elements were not discovered. After Mendeleev introduced the periodic table, they came to know that these elements are discovered. They came to know that these elements never participate in chemical reaction because they have octet configuration in the valence shell. Neon, if you take that configuration is 1s2, 2s2, 2p6. So the valence shell is having 8 electrons. So octet configuration is there, therefore stable. Helium 1s2 doublet configuration. Rest of the elements octet configuration. Therefore, they are not they were not participating in chemical reaction. Therefore, valence is 0. So 0 group. IUPAC group number is 18. Then these elements they thought that were not participating in chemical reaction. Therefore, they said these elements were inert gases. All the elements are gases. Next, these elements are called aerogens. Why? Because these elements present in the atmospheric air. Then these elements are called rare gases because their availability is very low. Therefore, rare gases. But after some time, they came to know that these elements involving in chemical reaction under certain conditions. Then xenon compounds were discovered. How they discovered xenon compounds in the sense? Bartlett conducted an experiment. What is the experiment means? He took oxygen gas and a PTF6, plutonium hexafluoride. He treated both. He got the compound O2 plus PTF6 minus. Like this compound he got, this the color of the compound is red. After completion of this reaction, he got an idea. That is, he considered xenon. Xenon ionization energy and O2 ionization energy are equal. Therefore, when oxygen involved in chemical reaction, why not xenon? Then he tried the reaction. Instead of oxygen, he took xenon and PTF6. He conducted the experiment. He got a so-and-so compound he got. So-and-so compound he got. This color is what in the sense red. Then Bartlett told that these elements also can involve in chemical reaction. So that these elements are called noble gases. Then they said name of these gases are noble gases. Before Bartlett, they thought that these elements never involve in chemical reaction. Therefore, they said inert gases. After Bartlett this experimental proof, then these elements were named as noble gases, not inert gases. Sir. So this 18th group elements, we can call them as noble gases, we can say. Then, which noble gas present in the atmospheric air to large extent means argon. Argon is present in the atmospheric air in the large extent. Okay. Then how to get radon? How to get radon means radium on radioactive disintegration produces radon. Radium, atomic number 88, mass number 226. This is radioactive substance. Therefore, it is emitting radioactive ray. It emits alpha ray for atomic number 2, mass number 4. Then radium becomes radon. Now atomic number is 86. Here 88, here 2 is there, therefore 86. Here 226, here 4 is there, therefore 222. radon is active. So how we are getting radon means radium on disintegration, radioactive disintegration becomes a radon. Then what is the sources of helium gas? Sources of helium gas we'll see. Sources of helium gas is one is pitch blending. Pitch blending is one source. Then monazite. Monazite. Next cleavite. Cleavite minerals. Then natural gas. These are containing helium gas. These are giving helium gas. Then we'll see physical properties of these elements, group 18 elements. Their noble gases are monoatomic, we can say. They will not exist as diatomic molecules. They are monoatomic molecules. Noble gases are colorless. They are not having any smell. They do not have any taste. They are slightly soluble in water. Why they are slightly soluble in water means they will make only van der Waals force with water. That's why slightly soluble in water. Down the group of noble gases, what happens to the solubility? Solubility increases. Why? Because down the group size increases, so van der Waals force increases, so solubility in water increases. When noble gas is in dissolved form in water, what type of intermolecular force is possible? Means noble gas is a non-polar, therefore water is polar, therefore water will exist, water will give dipole. Noble gas will be induced, therefore noble gas becomes induced dipole. So between water and noble gas, what is the intermolecular force? Means a dipole, induced dipole attraction is possible. Then down the group of noble gas, melting point, boiling point, density, tendency of liquefaction increases because van der Waals force increases down the group. Then generally melting and boiling points of noble gases are very low because intermolecular force, van der Waals force is very low for noble gases. Then chemical properties of noble gases we'll see. Before that, which noble gases involve in chemical reaction, which noble gases will not involve in chemical reaction, that we'll see. Now we will take helium, we will take its configuration is 1s2. The valency shell is completely filled. Its ionization energy is high. Its valency shell is not having any vacant orbitals. Therefore, it is not involving in chemical reaction. It is inert. Next, we will take neon. Neon electronic configuration is 1s2, 2s2, 2p6. This valency shell is not having any vacant orbitals. This valency shell is not having any vacant orbitals. And also it is having high ionization energy in the second period. Therefore, this neon also is not involving in chemical reaction. So, helium, neon, argon compounds were not discovered so far. Next, we will take krypton. Krypton compound KrF2 is traced. KrF2 compound is traced. Next, we will take xenon. Xenon electronic configuration we'll see. Xenon electronic configuration is krypton 4d10, 5s2, 5p6. This valence shell is having vacant d orbitals. Due to vacant d orbitals, it involved in chemical reaction. Many compounds of xenon were discovered. Then we'll go for radon. Radon is having vacant d orbitals in the valence shell, but we are unable to isolate radon because of its very low half-life period. Therefore, studying chemical properties about radon is difficult. Radon also involving in chemical reaction. Its compound RnF2 is identified in the radio tracer. radio tracer technique using that RNF2 is identified. Then we will see xenon compounds preparation. We will see xenon compounds preparation. We will take a xenon excess. We are taking xenon excess and we will take fluorine. Temperature provided is 673 Kelvin. Pressure is 1 bar. Pressure is provided. Xenon difluoride is produced. Xenon difluoride is produced. Next we will take xenon gas. We will take. Then fluorine gas we will take. We will take them in the ratio 1:5. 1:5 ratio we will take. We will provide a temperature 873 Kelvin and a pressure 7 bar. We are getting xenon tetrafluoride. Xenon tetrafluoride we are getting. Then we will take xenon. Then we will take fluorine. We will take them in the ratio 1:20 ratio. We are providing temperature 573 Kelvin. Pressure 60 to 70 bar pressure will provide. We will get xenon hexafluoride. We will get xenon hexafluoride. We are getting. Then we will take xenon tetrafluoride. We will take xenon tetrafluoride. We will take O2F2. We will provide temperature 143 Kelvin. We will get what in the sense xenon hexafluoride we will get. We are getting xenon hexafluoride. We are getting. Okay. Xenon fluorides are colorless crystals. Colorless crystals. Xenon fluorides undergo sublimation readily at 298 Kelvin. Xenon fluorides act as powerful fluorinating agents. Xenon fluorides act as powerful fluorinating agents. Then xenon fluorides undergo hydrolysis even with a trace of water. Even with a trace of water, xenon fluorides undergo hydrolysis. So xenon fluorides undergo hydrolysis even with a trace of water. Now we will take xenon fluoride XeF2. We will take this with water. What we will get in the sense xenon HFO2 we will get. Xenon undergoes reduction. Oxygen undergoes oxidation. Fluorine oxidation number no change. Xenon tetrafluoride will take. This undergoes hydrolysis. We are getting xenon trioxide, then O2 and HF. Here if you see xenon oxidation number +4, that is becoming 0 here. Reduction. Xenon +4 becoming xenon +6 oxidation. Oxygen oxidation number -2 becomes 0 oxidation. Like this possible in the hydrolysis. Then xenon hexafluoride will take. This undergoes hydrolysis to give what in the sense xenon trioxide and HF. Here xenon is +6. Here also xenon is +6. No change in oxidation number. So when xenon hexafluoride undergoes hydrolysis, no change in oxidation number. That means it is not a redox reaction. But XeF2 hydrolysis, XeF4 hydrolysis or hydrolysis, these are redox reactions. XeF6 hydrolysis is not redox reaction. Next, XeF6 on partial hydrolysis. On partial hydrolysis gives XeOF4. XeOF4. That means 2 fluorine atoms are replaced by 1 oxygen atom. When XeF6 undergoes hydrolysis, partial hydrolysis, we are getting XeO2F2. XeO2F2. Here 4 fluorine atoms are replaced by 2 oxygen atoms. This is complete hydrolysis. All the fluorine atoms are replaced by oxygen atoms. All the 6 fluorine atoms are replaced by 3 oxygen atoms. Therefore, we can say it is complete hydrolysis. These two are partial hydrolysis. These two we can say partial hydrolysis. This we can say complete hydrolysis, we can say. Sorry. Next, xenon fluoride will take XeF2. Then phosphorus pentafluoride will take phosphorus pentafluoride. Here, what is the reaction takes place? Here we will see. Xenon difluoride structure we will write. Xenon difluoride is linear like this. Xenon difluoride is linear. PF5 will take PF5. PF5 we have taken like this. Now this fluorine is having 3 lone pairs. This is a donating lone pair to this fluorine. This phosphorus. This bond is shifting like this. Now XeF is losing the bond pair, therefore getting positive charge. Fluorine getting the fluorine. Phosphorus getting F minus, therefore PF6 minus. Now here XeF2 is donating F minus with what, in the sense with the F minus acceptor. PF5 is accepting F minus, therefore XeF2 is donating. Then in the nitrogen family, antimony will take SbF5. SbF5 will take. Xenon tetrafluoride will take. Now this is donating F minus, it is accepting F minus, therefore we will get XeF3 plus and SbF6 minus will take like this. SbF5 is accepting F minus. That means nitrogen family PF5, ASF5, SbF5, these and all accepting F minus. So xenon fluoride is donating F minus. Okay. Next step. We'll take XeF6 will take. Then we will take NaF will take. NaF we are taking. So what we are getting, in the sense Na plus XeF7 minus. Here this XeF6 accepting F minus, this NaF donating F minus. So which and all donate F minus means NaF, KF, RBF, cesium fluoride, alkali metal fluorides donating F minus, xenon fluoride accepting F minus, XeF6 accept F minus and becomes XeF7 minus, and this Na plus we have written. Like this complex is formed, we are saying. Okay. Next, we'll see the uses of noble gases. Now we will take helium. Helium gas is used in the balloons for studying weather conditions. Therefore, it is used in meteorology. Why we are using helium gas instead of hydrogen? Hydrogen is lighter than helium. Even then, why we are using helium, in the sense helium is not burning, but hydrogen will catch fire. Therefore, we are using helium, though hydrogen is lighter. Then for respiration, we are using this helium. For respiration, actually oxygen only will be used. Why we are using helium? That we will see. Now we will consider sea divers. Now we are considering sea divers. Sea divers, they will use oxygen gas for respiration. That oxygen gas they will take in the cylinders. In that oxygen gas, what will be there means helium and oxygen will be there. This gas they will use for respiration. Why they are using this gas for respiration? In the sense ordinary air contains nitrogen and oxygen. When these sea divers go into the deep of the sea, what will happen means high pressure will be there. Why high pressure? Atmospheric pressure plus that depth of the sea, that is exerting pressure. Therefore high pressure acting on them. Under high pressure, nitrogen dissolves to more extent. Nitrogen gas dissolves to more extent. Nitrogen gas dissolves to more extent under high pressure. When the sea divers come to the surface of the sea, what happens means pressure will be atmospheric pressure, that will be low. Now dissolved nitrogen gas becomes undissolved nitrogen gas. Therefore the nerves, the walls will be expanded. Therefore they will get pain, that is called bends. So and so is happening because solubility of nitrogen here is high. Solubility of nitrogen becomes low here. Therefore when they come from ear to ear, the dissolved nitrogen becomes nitrogen gas. Therefore the valves becomes expanded. Therefore they will get paining, that is called bend. To avoid this, nitrogen is replaced by helium, because helium solubility is very low even at this place. Therefore this can be avoided. Therefore sea divers are using helium plus oxygen gas but not nitrogen plus oxygen. Therefore they are diluting oxygen gas using helium but not nitrogen. So helium is used by sea divers, we can say. Then liquid helium is used as cryogenic liquid. Liquid helium is used as cryogenic liquid. Cryogenic liquid means that will provide very low temperature. Liquid helium is providing 4.2 Kelvin, which is used as a cryogenic liquid. Then liquid helium is used as a gas cooled nuclear reactors. Helium is used in gas cooled nuclear reactors, we can say. Next, neon. Neon is used for advertisement purpose. In the advertisement purpose, if you see colored lights will be used. In that lights, neon gas is present. Then this neon is used by which one, in the sense in the aircraft it will be used. In the aircraft, in the light bulbs it will be used. Why? Because neon light can penetrate even through fog and mist. Neon light emitting light, neon bulb is emitting light. That light can penetrate through fog and mist. Therefore neon lights will be used for warning signal illuminations. It can travel long distance, even it is visible via fog and mist conditions. Therefore neon lights is used for warning signal illuminations. Then uses of argon, will say. Argon is used to provide inert atmosphere. Argon is providing inert atmosphere, we can say. Then argon is used in electric bulbs. This argon is used in electric bulbs, we can say. So this argon gas is used at where, in the sense electric bulbs we are using.